Imagine this. The sky splits apart in a brilliant burst of orange as a rocket erupts from the Earth. Frost lines race down massive fuel pipes like veins, and above it all, a camera the size of a car captures galaxies so distant, their light began traveling toward us before humans existed. This is not a sci-fi montage, it's just a snapshot of this past week in spaceflight. With explosions, surprise launches, and glimpses into the furthest corners of the cosmos, the pace has been nothing short of breathtaking. It all started with a bang literally when Ship 36, a prototype in SpaceX's Starship program, met a catastrophic end at the Massey test facility. Engineers and fans alike were caught off guard, still setting up cameras as the ship suddenly exploded during a static fire test. The blast sent a shockwave through the space community and left a smoldering scene of twisted metal, torn pipes, and scorched equipment. But even as the smoke cleared, SpaceX did what they have always done best: move forward. By early the next week, cleanup was already underway. Cranes swooped into action, scooping up debris into crates, sorting the larger parts for analysis. One crane, lifting debris near the tank farm, dramatically toppled over mid-lift, yet thankfully, there were no reported injuries. Just another twist in an already chaotic week. And while much of the infrastructure suffered damage, the quick disconnect system completely shredded the static fire stand itself, seemed to have made it through in relatively decent shape. Bruised, sure, but not beyond repair. That was a vital win. As engineers assessed the wreckage, it was clear that parts of Ship 36 might provide valuable insight. Pieces were not carted away immediately, likely preserved for inspection before recycling. Even from destruction, there was learning. The incident unexpectedly provided the broader community with a rare glimpse inside the ship's inner structure. Artists and modelers, like Chameleon Circuit, quickly used this unplanned opportunity to enhance their renderings, getting an up-close look at the evolving design of the Block II starships. For a project so shrouded in innovation, every visible bolt and bracket can offer an inspiration. Meanwhile, the future was rising just a few hundred meters away. Pad 2, the new testing and launch site at Starbase, was steadily coming to life. The cryogenic lines began frosting over during early testing, an icy sign that liquid oxygen was flowing through most of the newly installed pumps. 8 of the 9 LOX pumps were already in place, with the final one surely not far behind. The infrastructure itself was a major shift from previous builds. Rather than welded pipes that are cumbersome to repair, bolted flanges now dominate the design, allowing parts to be replaced with just a few bolts and a gasket. Faster, cheaper, and far more flexible. Cryogenic propellants naturally boil off, releasing dangerous vapors, and in earlier tests, these created thick ground-level fog banks. But at Pad 2, fan boxes have been installed to shoot the vapors upward, clearing the air more quickly and keeping ground crews and camera views safe and clear. This small change could make a big difference in launch readiness. The methane side of the tank farm was also coming together, with 6 of the 8 pumps already in place. Beyond that stood the massive water tank farm, essential for SpaceX's flame suppression system. With both the large and smaller tanks now nearly connected, the big question became, how exactly will they pressurize all that water to blast through the flame trench? That's where speculation turned wild. Observers began to suspect that SpaceX might use 9 small baby Raptor engines to do the job, engines traditionally meant for propulsion, now possibly being repurposed for water pressurization. If true, it would be a radically different approach from gravity-fed or gas-pressurized systems. It also reinforces a broader truth about SpaceX. They're not just building rockets, they're rethinking everything about how rockets are supported, launched, and recovered. The site was evolving daily. Workers were constructing a concrete blast wall to shield the water tanks, while the tower itself grew higher as more cladding was added. A new access hatch appeared, slightly repositioned from previous designs, hinting at better ergonomic or safety design. All signs that the pad was nearing readiness. Even the hold-down arms and booster quick disconnect mechanisms, so critical for launch operations, were being delivered and installed. The new generation of boosters will connect with 2 fuel lines instead of 1, so 2 quick disconnect arms are now being fitted. Back at the build site, things took a strange turn when Booster 16 was moved back inside the mega bay and had its hot staging ring reattached. Given that there's no flight immediately pending from Massey's, this was not about prepping for launch. It's possible the booster is simply being weatherproofed before being displayed or stored. Or perhaps SpaceX has another use in mind entirely, a wild card in the deck. Then, in a curious move, a ship transport stand began rolling toward the launch site. Could this be SpaceX's plan to perform a static fire of the next ship, possibly Ship 38, by welding this stand directly to the old orbital launch platform? The pad only needs to survive a couple more launches before its retirement. If successful, it would allow SpaceX to gather valuable re-entry data without delay. Meanwhile, over on the East Coast, Florida was stepping up fast. At Launch Complex 39A, construction of a flame trench identical in design to Pad 2 in Texas was already well underway. Progress here was swift. Inside an environmental tent, shielded from the elements, SpaceX was working on the new launch mount. And across the road, 17 separate spots had been set aside for building tower segments. That's enough for not one, but two towers, likely hinting that SpaceX plans to build a second Starship pad at the freshly cleared Launch Complex 37. As towers rise in Florida and the Giga Bay foundation work progresses at Roberts Road, it's clear this coast is becoming just as vital to Starship's future as Texas. While SpaceX moved at record speed, Blue Origin wasn't sitting idle. At their Florida site, construction surged. This location will soon be home to New Glenn, Blue Moon lunar landers, and perhaps even infrastructure from the Orbital Reef space station. New sections were already being staged for delivery. The site keeps growing. Back in Utah, a very different kind of test was unfolding. Northrop Grumman ignited its updated 5-segment solid rocket booster, a critical piece of the SLS program. The test began beautifully, with their new electronic steering system functioning well, until a dramatic failure at the nozzle cut the test short. Still, the early data was promising. Even failures move us forward. Meanwhile, in the sky above Earth, it seemed as if no moment passed without another rocket launch. Transporter 14 blasted off from Vandenberg, carrying 70 diverse payloads including Elara Sat and Starfish, Space's Otter Pup 2, destined to test docking maneuvers in orbit. Not long after, Axum's fourth private crewed mission soared to the ISS from Kennedy Space Center, with veteran astronaut Peggy Whitson leading a global team on a science-packed journey. Across just a few days, Falcon 9 rockets roared skyward again and again, 5 launches in total. Starlink batches continued to grow, and boosters landed with machine-like precision. At this point, SpaceX is not just launching rockets, they're refining the cadence of flight itself. And then, from far above the clouds, the universe whispered back. The Vera C. Rubin Observatory officially began its watch. With a 3,200 megapixel camera capable of imaging the entire visible sky every 3 nights, it's expected to generate more data in its first year than all previous observatories combined. Early images stunned even seasoned astronomers. The cosmic drama and cosmic abundance datasets revealed swirling galaxies, merging clusters, and shockwaves made of billions of stars. These aren't just pretty pictures, they are blueprints of our cosmic history. The Rubin Observatory will help map the Milky Way's structure, identify near-Earth asteroids, and perhaps even discover interstellar visitors. Its unique design cancels out diffraction spikes, producing smooth, natural-looking images that could help refine everything from dark matter models to planetary defense systems. And the best part? The data is public. Rubin's tools are available online, inviting students, scientists, and space dreamers everywhere to explore and contribute. In a decade, we may have cataloged 20 billion galaxies, and you might be one of the first people to discover one. So, after all that, what's next? As starships are pieced together and observatories peer deeper into time, we find ourselves on the edge of something enormous. This is not just a week in space history, it's the beginning of a new chapter. The rocket trails may fade, but the momentum builds. If that launch-fueled chaos and cosmic wonder got your heart racing even a little bit, go ahead and smash that like and subscribe. Until then, keep your eyes on the stars, your feet off the brake, and as always, I'll see you in the next launch.